In this demo, we have planned to put empirical model by extending our ProMo ontology without any problem. This empirical low-order model has been developed for describing the mixing of two powders by DCS, and it consists of an ordinary differential equation of dy, which is derivative with respect to time, as you can see here. In this equation, alpha exhibit the periodic motion of the mixer, which we define as a sine function called Stirrer function, with A refer to stirrer amplitude, F refer to stirrer frequency, and T refer to time. Gamma and beta are positive coefficient depending on the mixer geometry, particle size, and densities. Yn is mixing function which varies from -1 to +1. -1 exhibits stable unmixed state, 0 exhibits perfectly mixed state, and +1 exhibits unstable unmixed state. Now, let's look at the ProMo ontology we've been working so far. We need to know, once we define our ontology and we set up a variables and equations, we cannot remove an existing ontology domain. As you can see, remove button is not active anymore. However, we can extend the ontology. For putting this empirical model, let's add mixing domain as physical subdomain. Mixing domain has interrelation. Here, we just need to add a new variable class called parameter into behavior component node. Now, let's save the ontology and move to the equation builder to define variables and equations for this empirical model. In the equation builder, let's first define our port variable for the state variable class in the mixing domain. Y, which is mixing index, and it has node indices. Now let's define constant variables. The first constant variable would be beta, which is mixing beta function, beta parameter. The next one would be gamma, and now frequency. F, which is stirrer frequency. And it has unit of inverse second. The next one would be A, which is stirrer amplitude. And it has indices over node and time. And now let's define an equation. This shouldn't be port variable, so I will delete it and I will add. So this one is instantiation of y value. And it is the description would be f1 of the same dimension as y. And that's all with the constant variables. Now let's move to the parameter. To define stirrer function alpha, which define as a multiplied by sinus of t multiplied by frequency. We hit the enter and we describe this as stirrer function. Finally, we can go back to the state variable class to define a mixing function dy, which is alpha multiplied by gamma multiplied by y minus beta multiplied by y minus y1. We hit the enter and everything is okay. And now this is mixing function. Which we accept. Before we compute, let's edit the LaTeX notation from various aliases. So here we have beta, gamma, and alpha. And that's all. Let's compile to see the result. As you can see here, we have mixing domain with variables that we define, and also we get the equation that we were interested. And this is dy mixing function. That's all with this demo.